Chapter 7 starts off with a section called Polynomials because we are going to be looking at polynomials within Chapter 7, so it would probably be nice to know what they actually are. So taking a look, the first thing is the definition of not a polynomial, however, it will be a monomial. So different prefix on that, and we will talk here in a minute about those prefixes and what they do mean. So we start with the definition of a monomial. A monomial is a number, a variable, or a product, which remember product means we're going to multiply, of a number and one or more variables. Now here's the key. If it does have variables, those variables must have whole number exponents. So in our last section, we had fractional exponents. No good. Well, fractions can be made into decimals. Can't have decimal exponents either. Well, in a few sections ago, we had negative exponents. You can't have those either. So whole numbers, 0, 1, 2, 3, 4, 5, and so on. So when you're looking to decide if something is a monomial or not, first, is it just a plain number? It can be any plain number. Fractions are good, so are negatives, so are decimals. Variables, any variable is fine. It can be a product of numbers and variables. The big thing you have to watch are exponents. Exponents must be whole numbers. So deciding if the following are monomials, letter A is 7. Well, 7 is just a number. Technically, it's to the first power, so yes, that would be a monomial. For part B, 5x squared y to the 5th. Number variable combination. They are separated by multiplication, product, so that's good. Now let's take a look at those exponents. 5 is really to the first, x is to the second, y is to the 5th, all whole number exponents. So yes, that one is also a monomial. A lot of students will tell me for letter C that that's not a monomial because it's division, not multiplication. I'll throw you a curveball if that was your thinking. I'll bring this x to the top of the fraction, which means it will then multiply the x. But what happens to an exponent, which right now that x does have an exponent of 1, if I take the reciprocal, if I move it from the denominator to the numerator, you have to take the opposite of the exponent. Usually we want the positive exponent, so we would take it to the denominator. However, to show those of you that said that's division, we can't have that. Well, now I made it multiplication. Now is it a monomial? No. Your answer is still no, because now I have this negative exponent. I am not allowed to have negative exponents, therefore that is not a monomial. For letter D, 3.5 xy to the 8th. Some students will tell me no, that's not a monomial because they don't like the 3.5. However, you can have a decimal value. You can't have a decimal as an exponent. That 3.5 is not an exponent, so it is okay. That 3.5 really to the first power, x also to the first, y is to the 8th, all whole number exponents. Those terms are separated by multiplication, so yes, that is a monomial. So now we know what monomials are, so let's take this a step further and talk about a polynomial. If we look at prefixes, mono means one, poly means many. So a polynomial can be a monomial or a sum, which means addition, of monomials. So I could put letters A, B, and D together, have to leave C out, it's not a monomial, add those together, and that would be a polynomial. 7 plus 5x squared y to the 5th plus 3.5 xy to the 8th. That is a polynomial. It can just be a simple monomial, or it can be a sum of monomials. So a polynomial with two terms, if we think about these prefixes, poly meaning many, mono meaning one, any ideas of what prefix would mean two? It is binomial. Bi, prefix meaning 2. My first term, 7x. My second term, 3. Monomial, monomial being added together. Well, let's think about a prefix that might mean 3 terms. Right now, one term, monomial, 2, binomial, 3 terms is a trinomial. Prefix being tri. 3 terms. My first term, x squared. My second term, 4x. Whoa, wait. This is subtraction. I thought it had to be the sum of monomials. Don't forget, subtraction is really adding the opposite. So I could, if I wanted to, even though I'm not going to, make that plus -3. So my third and final term there is -3. So we are good with that. A polynomial is said to be in standard form when the exponents on the terms decrease from left to right. So we are going to look at the exponents on the variables. So both of my examples here are in standard form. This x is to the first. Constants, plain numbers, I could really put an x on there, but it would have to be to the 0 power. So here's x to the first, then x to the 0. That's good. 2, 1, and again this 3 would have an x to the 0 on it as well. So for standard form, you're going to start with your highest exponent and then work your way down to the right to the smallest exponent. Speaking of the highest degree, the degree of a polynomial is the highest degree of the terms. So whatever term you decided to put first, you put that first in standard form because it had the largest exponent. Well, that exponent is then the degree of the polynomial. So if we take a look at our practice, we will write it in standard form and then identify the degree and the number of terms. So if I look -3n squared plus 5n to the third, it is a polynomial. My exponents are whole numbers. However, exponent of 2, exponent of 3, that is not in standard form. Watch the sign in front. 5n to the third comes first, then minus 3n squared. Exponent of 3, exponent of 2. There is standard form. The highest exponent, we just put that first, is 3. Well, a third degree polynomial actually has a special name. How else could we read this other than 5n to the third? Most of you would say 5n cubed. Well, with a degree of 3, we would call that a cubic polynomial. And actually, we can be even more specific than calling it a polynomial. It has 2 terms, 5n to the third, -3n squared. 2 terms is a binomial. So if I was classifying this polynomial, I would say that it is a cubic binomial. Cubic meaning the degree is 3, binomial meaning it has 2 terms. For 8w to the 5th, that is also in a polynomial. It has a whole number exponent. Well, there's not much going on there, so that is in standard form. The degree is the highest exponent. Well, it's the only exponent on a variable. It is 5. So we would consider that just a 5th degree polynomial, no special names for those. The type of polynomial, there's one term. One term, monomial. And for letter C, -1 plus 9d squared plus 4d. All whole number exponents. It looks good. It is a polynomial. However, it is not in standard form. We need to start with the highest exponent on the variable, which is 2. This is really to the first. No variable there. That term will come last. So 9d squared is my first term, plus 4d, and then minus 1. Make sure you pay attention to the signs in front of each one of those terms. 9d squared is positive. 4d is positive, but that 1 is negative, so make sure you bring that minus with you. Highest exponent is 2. Now this is one that might be weird because the prefix doesn't necessarily make you think of 2. However, a second degree polynomial is called a quadratic. So again, I know usually with that prefix quad, we tend to think 4. However, a second degree polynomial is considered a quadratic. How many terms does it have? 3. Which makes it a quadratic trinomial. So 1 term monomial, 2 terms binomial, 3 terms trinomial. Anything bigger than 3 terms is just a polynomial. We don't have any other prefixes that we put on there. Well, I see a second degree polynomial is a quadratic, third degree cubic. Anything bigger than 3 is just that number degree polynomial, 4th degree, 5th degree, and so on. Let's take a step back here. Let's look at this example here, the 7x plus 3. The highest exponent I see there is 1. So it is a first degree polynomial. However, we've seen 7x plus 3 before. When we graphed those, what did we say it would have as a graph? A line. A first degree polynomial is a linear polynomial. Technically, it's a binomial because we have that mx plus b. We have 2 terms. It could be a monomial if we just had the 7x on there. There's a linear monomial. All possibilities. I'm going to throw one more in here for us. I'm going to say letter D, and I'm going to make it, my favorite number is 12, so I'm going to do 12. Well, that is its own standard form. Remember, if I think back, on that plain number, I had to add a variable and raise it to the 0 power. So plain numbers do have a degree of 0. They are called constants. They're plain numbers. So that is a constant degree. So if you just have a plain number, the technical term for those is a constant, so that would be your degree. It would also be a monomial. To be a constant, it has to be a monomial. If it's anything more than that, then it couldn't be a constant, then it would have to have a higher degree than that. Taking a look at actually using a polynomial, we're told that polynomial negative 16t squared plus v sub o t plus s sub o is going to represent the height in feet, so this is going to represent height of an object. Now it tells us v sub o is the initial velocity, s sub o is the initial height of this particular object, t is the time in seconds. So all that information is going to become important. It asks for a polynomial that represents the height. Well, this is the polynomial that represents the height. We're going to use that. If the initial velocity is 40 feet per second, initial velocity, we're told, is that v sub o. So 40 is going to be substituted in for v sub o, and the initial height is 5 feet. Well, here we were told that s sub o is the initial height. So 5 is going to go in for s sub o. Sub in. So I have negative 16t squared. We were never given a time. That's what t stands for. So I can't plug anything in for that. V sub o, 40. And then we have our t plus s sub o, which is 5. That's it. That's all I can do with that. For part B, what is the height of the baseball? Height, there's our polynomial that we have after 2 seconds. Well, what does 2 seconds represent? That is a time. So we are going to plug 2 in for t into this polynomial that we found in part A. So I have negative 16 times 2 squared plus 40 times 2 plus 5. I could plug that in on my calculator or do a little mental math here. Exponents come first, so 2 squared is 4. 4 times negative 16 would be negative 64. 40 times 2 is 80. So I have negative 64 plus 80 plus 5. And you end up with 21. Now, that 21 means something. What is the height of the baseball? It is 21 what? The height of the baseball is 21 feet. If I were to classify that polynomial that we just used, it is a second degree, which means it's a quadratic. It has 3 terms, which means it is a trinomial. I would say that we just used a quadratic trinomial. It is in standard form because it starts with that highest exponent on t and works its way down to the smallest exponent. Constants always come last. So again, looking at polynomial is made up of monomials, plain numbers, variables, a product of numbers and variables, key there being all exponents need to be whole numbers. No negatives, no fractions, no decimals, as exponents. Standard form for a polynomial starts with the highest exponent on a variable and works its way down to the smallest exponent on a variable, which would be a constant at the end if there is one. A 0-degree polynomial, just plain numbers, we say are constants. In terms of the degree of, if it is 1, if the highest exponent is 1, that is a linear polynomial. Degree of 2, quadratic. Degree of 3, cubic. If that has one term, we would classify it as a monomial, 2 terms, a binomial, and finally 3 terms would be a trinomial. Anything more than 3 terms is just a polynomial. Anything with a degree above 3, 4th degree, 5th degree, and so on.